Hello everyone, I'm Brandon Ordoñez from ECE41 and today I will be performing our experiment number 6 for our robotics laboratory, which is all about accelerometers. Hello everyone, so now let us begin with the objective. So this experiment will enable the students to control the angular displacement of the robotic arm using the accelerometer. To create a computer program user interface to display data coming from Arduino. So instead of doing this, I will show you later the data coming from the Arduino through our serial monitor. So now, this would be our problem. Create a program for the microcontroller that will control the angular displacement of the servomotor connected in the robotic arm by using an accelerometer. The accelerometer will be placed at the forearm. As the forearm moves, the X, Y, and Z value will be used to compute the angle of the arm. The angle created by the forearm will be imitated by the robotic arm. So first, let's go to our circuit schematic here. So this would be our Arduino Uno and this would be our breadboard. And this would be the servo motors representing the three axes for the robotic arm. One would be for the x-axis, which would be at pin 2. Next, the pin 4 servo motor would be for axis Y, and the pin 7 servo motor would be for axis Z. So now, for this experiment, I have used an MPU 6050 board or an accelerometer with a gyroscope. So now let us discuss the circuit. So first, the 5 volts VCC of the Arduino Uno is connected to the positive terminal of our breadboard. Next, the ground port of our Arduino Uno is connected to the ground terminal of our breadboard. Next, for the MPU 6050, the VCC is connected to the positive terminal of our breadboard. The ground port of our MPU 6050 is connected to the ground terminal of our breadboard. The SCL is connected to the A4 pin, the analog in 4 of our Arduino Uno, and the SDA is connected to the analog pin 5 of our Arduino Uno. Next, for the first servo motor, for axis Z servo motor, it is connected at pin 2 of our Arduino Uno. The VCC pin is connected to the positive terminal of our breadboard, while the ground pin of our servo motor 1 is connected to the ground terminal of our breadboard. Next, for the axis Y servo motor, the pulse pin is connected to pin 4 of our Arduino Uno. The VCC pin is connected to the positive terminal of our breadboard. And the ground pin is connected to the ground terminal of our breadboard. Lastly, for the axis Z servo motor, the pulse pin is connected to pin 7 of our Arduino Uno. Next, the VCC pin is connected to the positive terminal of our breadboard. And lastly, the ground pin of our servo motor is connected to the ground terminal of our breadboard. So after the proposed circuit assembly, this would be our main circuit schematic. So again, same as before, this would be our Arduino Uno and this would be the three servo motors used to represent the robotic arm, and this would be our MPU 6050. So again, let's discuss. All of the positive terminal pins of our MPU 6050 servo motors are connected to the 5 volt terminal of our Arduino Uno. Next, on the other hand, all of the ground pins of our components, servo motor 1, 2, 3, and our MPU 6050 are connected to the ground terminal. Next, the SCL is connected to pin A5. Next, the SDA is connected to pin A4. Next, servo motor. For servo motor 1, which is connected at pin 2. Next, servo motor 2, which is connected at pin number 4. And lastly, servo motor number 3, which is connected at pin 7. So after the schematic, let's proceed to the code. So initially, I've included the code that I have found on the internet includes the library for wire and servo. Next, for the servo, this would declare the variable names for the servo 0, servo 1, servo 2. Next, const in MPU, this would be for the MPU 6050. Next, in 16/T, this would be for the accelerometer and the gyroscope. Next, the integer for the minimum value is 265. Next, the integer for the maximum value is 402. Next, double X, Y, and Z. So after that, we would go to the void setup portion of our code. So these are for the codes for the wire library used. Wire begin transmission, wire write, wire end transmission. Next, serial begin, servo 0 attached to. This means that servo 0 is for the one that's connected to pin 2. Next, servo 1, this means that the servo connected to pin 4 would be servo 1. And lastly, for the servo connected at pin 7, it is considered as servo 2 for this code. Next, for the main loop, wire begin transmission, MPU address, wire write, 03B, wire end transmission, pulse, there. Next, wire read, 8, wire read, for the X axis of our accelerometer. For the Y axis, it has the same code, and also for the Z axis of our accelerometer. Next, this would be for the angles that would be recorded initially. So these are the code. Next, for X, this portion is for converting the derived angle into degrees, since initially the angles that are derived are in radians form. Next, this part of the code will show the message in our serial monitor, and it shows the value stated, angle X, next angle Y, and angle Z. And lastly, this would be for the value that would be received by our servo motor. Okay. So after that, this would be the code that will enable the movement of our servo motors depending on the received value for servo 0, servo 1, and servo 2. And lastly, this would display the values received by our servo motors. Now, for lastly, the delay 500 means that the loop repeats every 500 milliseconds. So now, let us see the results of this circuit. Hello everyone, so now let's begin with our experiment. So first, I will upload our code, our Arduino sketch, to our Arduino Uno right here. And now that it's done uploading, let us observe the results. So first, let us observe the Z-axis. This would be our servo motor for the Z-axis. So I will try to lift it up. So as we could see that whenever I lift our MPU 6050, the axis of our servo motor changes. So next, let us observe the y-axis here. So whenever I'll change the axis for our gyroscope in the y-axis here, the servo moves. See. So now, at a steady state, right here, our y-axis is at 91.71 degrees, while our z-axis is at 64 degrees, and our x-axis is at 91.83 degrees. So there. So now let us observe the effects on the x-axis. So there, whenever I change the position of our gyroscope, the position of our the axis of the movement of our servo motor changes. So currently it is at 180 degrees for our x-axis. So again, so when there, so now it is at 355 degrees for our x-axis. So again, let us observe. So first, for the z-axis, I will lift up our gyroscope here. So currently it is at 10.69 degrees, and when I put it down, it is now currently at 358.29 degrees. Next, I will try to manipulate the our y-axis servo motor. So next, there. So currently, currently it is at 93 degrees, and when I put it down, it is currently at 96.79 degrees. So when I try the other way, it is currently at 271.89 degrees. So next, for our x-axis servo motor, so when I moved it that way, it is now currently at 225 degrees. Wait. So again, let's observe the effects on our X servo motor. So when I move it like this, our x-axis is currently at 194 degrees. And when I put it this way, it is now currently at 200 degrees again. So when I put it this way, it is now currently at 352.72 degrees. So to recap, this is our z-axis servo motor, this is our x-axis servo motor, and this would be our y-axis servo motor. And this would be our MPU 6050 as described in our schematic diagram shown earlier. So let's try it again one last time. So first, for the x-axis, there. Next, for our y-axis servo motor, there. Next, for our z-axis servo motor. So that is it for our experiment on the robotic arm using an accelerometer.